In this video, we will solve problems from exercise 6.4. Let's look at question number 5. Find the acute angle between the following lines. So you're given two lines and you're asked to find the acute angle between these two lines. So the acute angle between these two lines will be the same as the angle between this vector here and this vector here. So let's define, let vector B is equal to I cap plus 2j cap minus 2k cap. And let's define vector D as minus I cap minus 2j cap plus 2k cap. So this is my vector B and this is my vector D. So now cos theta would be equal to magnitude of the dot product of B and D divided by magnitude of B times magnitude of D. So that's equal to, the numerator will be magnitude of 1 times minus 1, which is minus 1, 2 times minus 2, be minus 4, minus 2 times plus 2 will be minus 4 again, divided by square root of 1 squared plus 2 squared plus 2 squared times square root of 1 squared. I'm not putting the minus because anyway when you square it, it will be a positive number. So plus 2 squared plus 2 squared, which is equal to, numerator will be 9 over root of 9 times root of 9. So that will be equal to 9 by 9. Therefore, our cos theta is equal to 1. Therefore, theta is equal to 0 degrees. In the second problem in question number 5, you are given the Cartesian equations of one of the line and you are given the parametric form of the equation of the other line. Now for the Cartesian form, 3, 4 and 5 will be the direction ratio. So if you have a vector with 3 I cap, 4 j cap and 5 k cap, then this vector, this line will be parallel to this vector. So let's define vector B as 3 I cap plus 4 j cap plus 5 k cap. Similarly, we can define vector D, which is this one, as 2 I cap plus j cap plus k cap. So using the same method, our cos theta will be equal to magnitude of B dot product with D divided by vector B into vector D. That is equal to, so we have 3 times 2, which is 6 plus 4 plus 5 divided by root of 3 squared plus 4 squared plus 5 squared into square root of 2 squared plus 1 squared plus 1 squared. So that is equal to 15 over root of 9 plus 16 plus 25. That would be square root of 50, and this would be square root of 4 plus 2, 6. So further this can be written as 15 divided by, you can write 50 square root of 50 as root of 25 times 2 root 6, which is equal to 15 over 5 times root 2 into root 6. So solving this, you get 3 over root 2, and you can write root 6 as root 2 into root 3. So that's equal to 3 by 2 times root 3. Therefore, our theta is equal to cos inverse of 3 by 2 times root 3. In the third case, we're given the Cartesian equations, but they are not in the form which is required. So we have to rearrange them. So let's take the first one, which is 2x is equal to 3y is equal to minus z. So we can rearrange this as x by 1 by 2 is equal to y by 1 by 3 is equal to minus z. And you can write the second one as similarly 6x is equal to minus y is equal to minus 4z as x by 1 by 6 and that's equal to minus y, and that is equal to z by minus z by 1 by 4. Therefore, our vector b here would be equal to 1 by 2 I cap plus 1 by 3 j cap minus k cap. And our vector d will be equal to 1 by 6 I cap minus j cap minus 1 by 4 k cap. Therefore, our b dot product with d would be equal to half into 1 by 6, which is 1 by 12 minus 1 by 3 plus 1 by 4, and that's equal to, keep 12 as the denominator, then 1 minus 4 plus 3. That would be 4 minus 4 by 12. That's equal to 0. Therefore, our cos theta would be equal to dot product BD divided by magnitude of B into magnitude of D, which is 0 over magnitude of B into magnitude of D, which is equal to 0. Therefore, our cos theta is equal to 0, which implies theta is equal to cos inverse of 0. Therefore, theta is equal to pi by 2. That's the answer. Question number 6. The vertices of triangle ABC are A 721, B 603 and C 424. Find the angle ABC. So you are given the vertices A, B and C. You need to find the angle A, B and C. So let's define our vectors. So OA vector will be 7 I cap plus 2 j cap plus k cap, and vector OB will be equal to 6 I cap, j will be 0, so plus 3 k cap, and vector OC will be equal to 4 I cap plus 2 j cap plus 4 k cap. Next, we need to find the vector AB and the vector BC. Then we can find the angle between these two vectors. So vector AB is equal to vector OB minus OA. So that will be equal to, our OB minus OA is 6 minus 7 minus I cap minus 2 j cap plus 2 k cap. Similarly, our vector BC can be defined as OC minus OB vector, and that will be equal to OC minus OB will be equal to minus 2 I cap plus 2 j cap plus k cap. So, if we find the angle between these two vectors, then we get the angle between, or the angle ABC. So, what is AB dot product with BC? AB dot BC will be minus 1 into minus 2 plus minus 2 into 2 plus 2 into 1. So that's equal to 2 minus 4 plus 2, which is equal to 0. Therefore, our cos theta, which is the angle between AB and BC, is equal to the dot product of vector AB and BC divided by magnitude of AB times magnitude of BC, and that's 0 we found here already, divided by magnitude of AB with magnitude of BC, which is equal to 0. Therefore, our theta is equal to cos inverse of 0, which is equal to pi by 2. That's the answer. Question number 7. If the straight line joining the points 2 and 4 and A minus 1, 4 minus 1, so we are given A here, is parallel to the line joining the points 0 to B minus 1, we are given a B here, and 5, 3 minus 2, find the values of A and B. So the line that joins these 2 points is parallel to the line that joins these 2 points. So if we consider this point as A and B, and let's define vectors, OA is equal to 2i cap plus j cap plus 4k cap, and let's define this point as B and say OB is equal to A minus 1 I cap plus 4 j cap minus k cap. Similarly, let's define this point as C and call this as OC vector is equal to 0, so it's 0 I cap, so it's 2 j cap plus B minus 1 k cap. Similarly, this will be D, so our OD vector is equal to 5 I cap plus 3 j cap minus 2 k cap. Next, we need to find the line joining AB. So, a vector AB will be equal to vector OB minus vector OA, and that is subtracting OB from OA, you will get A minus 1 minus 2 will be A minus 3, A minus 3 I cap, 4 minus 1 will be plus 3 j cap, minus 1 minus 4 will be minus 5 k cap. Similarly, the line which joins these two will be CD. So line CD is equal to OD minus OC. So subtracting OD from OC, we get 5 minus 2 as 3. Sorry, there's no I cap here, so this will be 5 I cap. Then 3 minus 2 will be plus j cap, minus 2 minus B will be plus 1, so minus 2 plus 1 will be minus 1, so you will get minus B plus 1 k cap. we are given that the two lines are parallel, which is AB is parallel to CD. Therefore, we should be able to write AB is equal to T times CD, where T is a scalar. So if we rewrite this equation as A minus 3 I cap plus 3 j cap minus 5 k cap, which is my AB, is equal to T times and my vector CD, which is 5 I cap plus j cap minus, or you can write this as plus minus B minus 1 k cap. Now, let's take the coefficients of j. So 3 should be equal to T. So you will have T is equal to 3, right? Similarly, A minus 3 will be equal to 5T. A minus 3 is equal to 5T. So if I'm going to substitute the value of T is equal to 3 here, you get your A is equal to 5 into 3 plus 3, which is equal to 18. So my A is equal to 18. And then similarly, minus 5 should be equal to minus B minus 1. T times minus B minus 1. So minus 5 is equal to minus T times minus B minus 1. So which is equal to 3 times minus B minus 1, which means minus 5 is equal to minus 3B minus 3. So further we can say 3B is equal to 2, or B is equal to 2 by 3. Therefore, A is equal to 18 and B is equal to 2 by 3. Question number 8. If the straight lines given by this and this are perpendicular to each other, find the value of m. So you have m here and you have a m here. Now these two lines are given, but they're not written in the form of a Cartesian equations. So let's rewrite them in the Cartesian equations form. So let's take the first one, which is x minus 5 divided by 5m plus 2. In the Cartesian equation should be y minus something. So rewriting this, if you multiply both sides, the numerator denominator by minus, then you will get it as y minus 2 over minus 5 is equal to, again doing the same thing here, z minus 1 divided by 1. And your second equation is x. So we keep it as x. This should be divide both numerator and denominator by 2. You will get y plus 1 by 2 divided by 2m is equal to, again multiplying the numerator and denominator by minus, you get z minus 1 divided by 3. Now we can see that 5m plus 2 minus 5 and 1 are the direction ratios of this equation. So therefore we can say a vector B is equal to 5m plus 2 I cap minus 5 j cap plus k cap, and we can define vector D with the direction ratios from the second equation. So which will be I cap plus 2m j cap plus 3 k cap. So we have the two lines. I mean the B and D are lines which are parallel to the first and the second equation. And it's given to us that these two lines are perpendicular. Therefore, vector B and vector D are perpendicular. Okay, so if they are perpendicular, then we know that a vector B dot product with D will be equal to 0. So this is given to us. So dot product of B and D can be written as 5m plus 2 times 1 plus minus 5 times 2m plus 1 here, 1 and 2, 3 is equal to 0. So further simplifying, you get 5m plus 2 minus 10m plus 3 is equal to 0. That implies minus 5m plus 5, or 5 minus 5m is equal to 0. So which means our 5m is equal to 5, which implies m is equal to 1. So that's the answer. Question number 9. That's the last one in this set. Show that the points 2, 3, 4, minus 1, 4, 5 and 8, 1, 2 are collinear. So which means they are on the same line. So let's call A point as 2, 3, 4 and define B as minus 1, 4, 5 and C as 8, 1 and 2. Now the equation of the line joining, A and B can be written as, using the Cartesian method, x, this can be my x1 here, 2 divided by minus 1, minus 2 will be minus 3, equals to y minus 3 by 4 minus 3 will be 1, equals to z minus 4 divided by 5 minus 4 is 1. Okay. Now if we call this to be some, say, t, okay, then our x value would be x is equal to minus 3t plus 2. So it will be 2 minus 3t. And our y value would be equal to, y is equal to t plus 3. And our z will be equal to t plus 4. Now if you observe the 8, 1 and 2, and if we replace t with the value minus 2, then let's see what happens. If t is equal to minus 2, then your x is equal to 2 minus 3 into minus 2, which is equal to 8. And my y will be equal to minus 2 plus 3, and that will be 1. And my z will be equal to minus 2 plus 4, and that's equal to 2. So we can see that our point 8, 1 and 2 is arrived by just replacing the value of t with minus 2. Therefore, the given points are collinear. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.